Well, hi guys, I want to run through, I guess you could consider this a review. It's simply the test that I gave last year, and I want to just run through it and let you see what I'm doing. Okay, and the first part here, I was asking kids to tell me if the series converged or diverged, and that was worth a certain amount of points. Then they had to justify their answers. They basically had to convince me or give me a correct reason or one of those diagnostic tests for their answer. So here we go. Number one, this answer is converge, and this is a direct application of a p-test. So my reasoning for this is a p-series, but I will not just stop there. I will say this is a p-series with p equal to 2, which is greater than 1. So I'm going to show Mr. G that I know what the cutoff is. I'm not just going to say p-series. All right, number 2, this is a geometric series which can be rewritten as pi over e to the n power. And of course, for a geometric series, we need that common ratio to be smaller than 1 if we want it to converge, but bigger than 1 if we want it to diverge. Now, pi is 3.14159, e is 2.71828. This fraction is a number a little bit bigger than 3 over a number a little bit smaller than 3. So pi over e is your common ratio, and that is larger than 1. So I would say diverge because this is a geometric series with the common ratio larger than 1. All right, number 3 here, I would say I would forget the plus 1 and I would simplify this into 1 over n to the 1/4. And I would not say this is a p-series. I would say I am comparing this to this summation of 1 over n to the 1/4. So if I throw out the fluff, then I compare to this series, 1 over n to the 1/4, which is a known divergent p-series. So I would have here just 1 second. I'm going to pause you guys while I have Miss K. Miss Reynolds, just come say hi on my video, just in case anybody knows you. These are my BC Calculus kiddos, and they will be all 12th graders. So how could they have known you in elementary school? Is it possible at all?
They could have gone to Dobie Primary, or Bucare or RSD Academy. That's where my kids went.
Okay.
And they might have known somebody that went to one of those schools.
Okay, well that's Miss K. Reynolds, and if you know her, she's giving you a shout out. So I'm going to pause you guys for just a second.
Okay. Did I just talk to them?
You did.
Well,
you're going to be on. Oh no, you just did that.
Oh, I did
Yeah.
already.
Yes.
Oh, well, shout out.
Yes, you're going to be on YouTube.
Oh my God.
No one will ever know though, except for those kiddos.
Yeah, now you just work it in here. Well, I'm going to come in here and work too.
I won't bother you.
I'll be real quiet.
Okay, as long as I don't bother you.
Oh, no.
Okay, we are back up and running here. And so we just did question number 3, and we compared that to a divergent p-series. So we're going to say this is divergent, and we're going to say comparison test. All right, number 4, this one I'm going to grab a screenshot of, but because I am not going to allow you to just tell me your hierarchy. You'll be able to do that on your AP test, but on this one I really want you to show me how you know what it does. So I've blown this up a little bit so we can take a look at it. Now, of course, in class we said anytime we're dealing with factorials or exponentials, we want to use the ratio test. So I'm going to apply that here. So we're going to start with the limit as n approaches infinity, absolute value of a sub n plus 1. Let me throw that in right there. And then, of course, replace that n with n plus 1 in parentheses, put that little squared on it. And then divided by the original, which means we're going to multiply by the reciprocal. And then we're going to clean this up. Now, my factorials are going to simplify to an n plus 1 in the top. I'm going to leave that over 1. And then we're going to take a look at this polynomial. 5n squared plus 7 over 5 times n plus 1 squared plus 7. Now, if we multiply the numerator together, we're going to end up with an n cubed. And in the bottom, we're going to end up with an n squared. So we are going to end up with a top-heavy fraction. And we know that the limit as n goes to infinity of a top-heavy fraction equals infinity, and which is a little bit bigger than 1. And so what we would say for this question is this is going to diverge by the ratio test. And I would need to see that you did the ratio test instead of just saying that. So this is what I would be looking for, is this work right here to back up your claim. All right, let's head back over here and take a look at the next question. Here I've got a -1 to an n plus 1, so I know I'm dealing with an alternating series. Let's see if I can spell that correctly. We're just going to do A dot C dot T, alternating series test. So there's two things I'm going to look for. Number one, what's the limit as n approaches infinity of your sequence? And here I've got n over 5n squared plus 1, and this is a bottom-heavy fraction. And so that limit as n goes to infinity is 0. So check, we got that first one down. And then number 2 are the terms getting smaller. And of course, if you plug in 1 or if you plug in 2 and plug in 3, you're going to see this denominator gets a lot bigger, which means the whole fraction gets smaller. So the terms are decreasing. So we've passed both checks there for alternating series test, which means that this is going to converge by the alternating series test. And I would need to see that you check these two things over here, or you can't get full credit for that. Now, on number 6, I'm going to not set up the ratio test here because just for time's sake, but I would need for you to set up the ratio test when you got factorials involved. This one is going to converge by the ratio test, and I would need to see you set up the ratio test and actually compute the limit of your ratio. And again, for the ratio test, you need that limit to be less than 1 to say it converges. Number 7 is very simple. This one is the nth term test. I'm not even going to apply any other test to this because the limit as n approaches infinity of that sequence is 5, because this isn't top heavy or bottom heavy, they're equal. And so we do the ratio of the coefficients, and we know from the nth term test that if this is not 0, then we can automatically say diverge. All right, let's take a look at this next question here. I just want to find the value. And we've done a couple of these in class where this is a separable geometric series. So I'm going to have the series from 1 to infinity. Boy, this number down here is really important. You've got to take a look. Is that starting at 1 or 0? That can catch you. And I'm going to have 2 over 4 to the n power, and then plus, see, I'm separating this into two series from 1 to infinity of 3 over 4 to the n power. So I have two geometric series, and all I need to do is take a look at my common ratio. Here my common ratio is 2/4, which is less than 1, which means that's a convergent series. And the second one has a common ratio of 3/4, which is also less than 1. So we're going to have a convergent geometric series, and it says find the value, so we're going to have to go through our formulas. So I need to find my first term, and that's why it's so important to look down underneath that silly e and see that n starts with 1. We've got to check that out. So I'll plug 1 in for n, and I'm going to get 2/4. So I'm not even going to simplify that to 1/2 yet. And then my common ratio is also 2/4. So I'll say that my sum is that formula we know, which is our first term divided by 1 minus the common ratio. And we get that that adds up to be 1. So that's the first sum. Now let's do the second one. Our first term on the second one would be 3/4, and our common ratio is, well, it's also 3/4. So I will do that my sum is first term divided by 1 minus the common ratio, and I'll get that that sum is 3. So added together, we are going to get that the value is equal to 4. All right, let's take a look then at our next page. Find the value of, I've got a series here that's separated by a minus sign. And we've seen this in class. This is one of those things that acts like a telescope, so we call it a telescopic series. And what we're going to do is plug values in and see if we can't figure out what's happening by looking at each individual term. So let's start by plugging in 0. If we plug in 0, we're going to get 1 over 1 minus 1 over 5. That's just the first term. So let's go to the next term. If we plug in a 1, we're going to get 1/3 minus 1/7. And nothing's canceling yet, so let's go to the next term. Now we're going to plug in a 2. We plug in a 2, we get 1/5 minus 1/9. Now I finally get something that is canceled here. Those 1/5 are going to go away. Let's plug in now. See, I plugged in a 0, a 1, and a 2. Now let's plug in a 3. So 1/7 minus, what's that going to be, 1/11? So I've got the 5ths have canceled, the 7ths have canceled. I'm going to try one more just to make sure I'm happy with this. I plugged in a 0, 1, 2, 3. Now let's plug in a 4. 1/9 minus 1/13. So we get the 1/5 to cancel, we get the 1/7 to cancel, the 1/9 to cancel, and everything else will cancel after that except for the 1 1/3. So this value is 4/3. All right, on the next question, I've got if the sum of the first 5 terms of this series is used to approximate the infinite series, then the absolute value of the error must be less than what value? So I don't have an alternating series, so the only other error statement we've had is the integral test error. And that error says if you're going to stop at the first finite terms of the series, then your error is less than the integral from where you stopped all the way out to infinity of 1 over, we'll change this to x cubed dx. And so that's what I will be looking for. And here I actually want you to figure out this value. And so for sake of time again, I want you to do that and find what the actual value of the integral is. But this setup will also give you some points. All right, the next question here is if we have the first 5 terms of the alternating series, then using the alternating series error, what's the maximum error here? This is that easy error. And that one is we only have to look at that next term. So all I have to find is a sub 6. So if we plug in 6 here, we're going to get 1/6 cubed, which I'm pretty sure is 216. But let's take a look at that again. Yeah, it's 216. So this is 1/216 is my maximum error there. All right, almost done with this little review for you. Let's take a look at number 12 here. I think you've seen this question very similar on your quiz. It might have been just like this on your quiz, but what you have in the denominators are the perfect squares, 1, 4, 9, 16, and 25. So I know down here I've got an n squared. And then on top I've got one more. So that, like if n is 1, then the top is a 2. If n is 2, the top is a 3. So they're going by ones, but they're starting at 2. So that's your formula for a sub n. And it says, does the series converge or diverge? And it's not alternating, so we're going to compare this to n over n squared, because that plus 1, when we're dealing with really big numbers, is not really going to do much, which is 1 over n, which is our divergent harmonic series. Now this last question, 13, I gave last year was a bonus question. And I'm going to leave you guys with that one. That's going to give you something to think about, because I'm not going to work the bonus question for you tonight. So I will see you guys tomorrow in class, and you can send me an email. I'll check it probably about every 30 minutes tonight. If you guys have any questions about this, or of course you can post it as a comment, and I'll check that as well. See you guys tomorrow.